Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and in this short video, another video in our series of videos dealing with coordinate geometry of the line, we're just going to discuss and present the different forms of an equation of a line, right? So this video is going to concentrate on the different forms. Okay, that's the shapes, the different characteristics, the different looks, okay, the different forms of equations of lines. Okay, so the different forms of these things. Okay, and the first form that I want to present, which is one that we developed in a previous video, is what's known as the point slope form. Okay, so the point slope form of an equation of a line. Okay, and the point slope form of an equation of a line looks something like this. It allows us to calculate the equation of a line when we've been given a point on the line and we've been given the slope. So we've been given, let's say, a point on the line x1, y1, and we've also been given the slope. We've been given the slope m. Okay. So the equation of the line, the formula for the equation of the line, given a point and a slope, is simply y minus y1 is equal to m times x minus x1. Okay, so this is what's known as the point slope form of an equation of a line. Okay, now what we can do with this is we can actually manipulate this particular formula around into another form, okay, which is known as the slope intercept form of an equation of a line. Okay, because we know that this is the slope here m, so we can solve this and put it in a different form, and it can give us what's known as the slope intercept form. So that's going to look something like this: the slope intercept form of an equation of a line looks something like this. Its y is simply equal to mx plus c. So if you know the slope, I suppose in this particular case here, you're given, I should have really written that down first, you're given m, the slope, and you're also given c, the intercept. Okay, that's called the intercept. That's why this is called the slope intercept form of a line. So you know the slope of the line and you know where the line intersects, let's say, the y-axis. Okay, and then another form of an equation of a line is what's known as the two-point form. Okay, so the two-point form of an equation of a line is where we're given 2 points on the line. Okay, so we're given x1, y1, and we're given x2, y2. Actually, this is we know what the slope of a line is. The slope of a line given 2 points is y2 minus y1 divided by x2 minus x1. So we could substitute that particular fact in here, and we could get rid of the fraction by multiplying across by x2 minus x1, which gives us the 2-point form, which is y minus y1 times x2 minus x1 is equal to x minus x1 times y2 minus y1. This is the form of an equation of a line. If you want to calculate the equation of a line when you've given 2 points, this is all you need to do. Okay, so let's have a look at some examples, okay, of how we can actually do these. Okay, so let's find the equation of a line. Okay, so let's find an equation of a line. So let's say example 1. Okay, let's say example 1 here. Okay, let's say we to find the equation of a line. So find the line. Okay, we've been given, let's say the point is 2, 3, and we've been given the slope is equal to 3. So we've been given these two things here. We've been given the point on the line and its slope. Okay, so from let's say a coordinate perspective, what we know is this is, let's say this is the x-axis and this is the y-axis. Okay, the point 2, 3, 1, 2, 3. Okay, the point 2, 3 is on the line, and it has a slope of 3, which means if I come out 1 unit in the x direction, I'm going to go up 3. So actually we're up here somewhere. So actually this is the line we need to calculate. We're given this, and we're given the point on the line, which is 2, 3. Okay, and we're told its slope, which means if I come out 1 unit, I'm going to go up 3 units. Okay, so I need to calculate the equation of this line, and here's the form here. So we know that y minus y1 equals m times x minus x1 is the equation of the line. So we have the point. The point is 2, 3. So this is going to be our x1, y1. And we have our slope is 3, so our equation becomes y minus y1. Well, y1 is 3, must be equal to m, which is 3, times x minus x1, which is 2. And when we just multiply out the brackets, we get y minus 3 is equal to 3x minus 6 here. Now, usually what we do is we rewrite this in a different form where we keep the x's to one side, make x, the coefficient of x positive, keep all the x's and the y's to one side, and the constants on its own. So we rewrite, let's say, okay, in the form ax plus by is equal to c. This is known as the general form of an equation of a line. Okay, so in this particular case here, this would become, well, we keep the x's where they are, so 3x. Bring the y over, it becomes minus y. That must be equal to leave the minus 3 where it is over here, and bring the minus 6 over, it becomes plus 6. So we end up with 3x minus y is equal to 3. That's the equation here of this particular line. Okay, let's consider another example. Okay, Okay, let's say example 2, and this time, let's say we've been given the slope